Hello, this video is for Stat 110 and is Module 2, Part 3. It includes a discussion of a smell test for Parkinson's disease. Okay, let's go ahead and get started then. So this test was developed at the University of Pennsylvania and is referred to as the UPSIT test, which stands for University of Pennsylvania Smell Identification Test. There is a video and also a wiki link regarding this test. And this test is used by the military, United States military, to detect head trauma, chemical exposure, and even post-traumatic stress disorder. So here's a short video about this test. I will let you hit pause here and watch that video. Okay, so this was a 40-item test, so it had 40 questions on it. And we are going to talk about a discussion regarding Parkinson's disease. So here's what that test looks like. They are asked to scratch this little area and smell, and then they are to identify which of the 4 items listed there does it smell like. Okay, so there's 4 questions or 4 options on every single little card or index card they have there on that smell test. That 4 options is going to be important because we're going to use that when we develop our reference distribution. Okay, let's consider 2 research questions here. So suppose we have a patient, let's just generically identify them as patient A, is believed to be in the preclinical phase of Parkinson's disease. Patient A is given this test, the smell test, and let us suppose that their score is a 19. So I want you to, or we're going to answer the following questions here. Does patient A perform better than an individual that cannot smell at all? So that would have complete olfactory dysfunction. So we're going to answer that first. And then the second question is, does patient A suffer from some level of olfactory dysfunction relative to the control group? And the control group is a group of individuals that are known not to have Parkinson's disease. Okay, so let us first consider question 1. So the number of trials for the reference distribution or for this investigation is going to be 40. So again, this smell test was 40 items. They had to go through and smell 40 different things and specify a response. If somebody has no ability to smell, then if we go back up and look at the note card there, they're going to just have to randomly select one of those 4. So a person that has no ability to smell has a 25% chance, or a 1 in 4 chance, of guessing correctly. So that's what we're going to use to build our reference distribution. So if somebody has no ability to smell, they're going to be 25% of the way up this number line. If I were to ask for the expected value, it would be 10, because I have 40 items on this test, and it would be 1 out of 4 correct if they were guessing, so that's 10. We're trying to figure out whether or not 19 is going to be an outlier. We want to know if 19 is going to be an outlier on the right-hand side because of the research question. And the research question is, does patient A perform better than an individual with complete olfactory dysfunction? Okay, so if we want to know if they're going to perform better, then that's going to be to the right-hand side. So this first research question is going to be a one-tailed right test. This is what the null and alternative hypothesis look like. And recall that patient A was able to correctly identify 19 correct. So the first question here is, what values would be considered as extreme or more extreme than the observed outcome? Well, if the observed outcome is 19, and this is a right-tailed test, And this is going to be 19 and 20, 21, 22, all the way up to 40. So those are going to be the quantities that we're going to use in computing our p-value. 19 up through 40. Okay, the next here is just to obtain another screenshot and add that to your notes. So I'll do the first one here with you. So over on our simulation app, we're going to have the two outcomes or labels are going to be correct or incorrect. An individual that is totally guessing has a 1 in 4 chance, so that's going to be 0.25 here in the P box. And the number of trials is 40. We're going to select count from our drop-down menu. Obtain several thousand. Doesn't matter really how many you obtain. Just get a lot of outcomes. The study outcome here was 19. So we want to put 19 in that p-value box. And this is going to be a right-tailed analysis. So that's going to compute, or the p-value for this particular situation is going to be 0.0014. And that is, again, the probability of obtaining a 19, a 20, a 21, 22, all the way up through 40. So it's a probability of getting something 19 or higher. Now this probability value is quite small. 19 certainly sits in the top 5% of the distribution. In particular, it sits in the top, I guess if I move that decimal over twice, it would be in the top 0.14% of the distribution. It's definitely within the top 5%. Again, we're going to want to take a screenshot of this. So go ahead and use your snipping tool or whatever you use. Save that onto your local computer somewhere. It doesn't matter anywhere. Give it some sort of name. And now when I go back to the notes, get that out of the way. When I go back to the notes here, I want to just drag and drop. Oops, sorry about that. I just want to drag and drop that file onto the dotted box. Now that just puts the file into your browser. Again, you're going to want to make sure and click Upload Image to Course Database to put it within your course notes. So it's a two-step process here. The first just puts it onto the browser, and then I need to click this to put it into the database. Now you can see that it is in the database. There's no more spot to upload. So I want you to take this p-value that you got from your screenshot, and I will let you answer these questions here. So what is the p-value? Make a decision, and then write a conclusion. So go ahead and hit pause on the video and answer question 2 there. Okay, let's now consider research question number 2. So research question number 2 was, does patient A suffer from some level of smell dysfunction relative to the control group? And that control group is known not to have Parkinson's disease. So information from up above here is that the control group, we know that they were able to get 28 out of the 40 correct. Okay, so not all of them correct, but a good number, a good proportion. Certainly a majority of those correct. So we're going to be using the 28 out of 40 for our building the reference distribution now down here for research question number 2. Okay, so again, does patient A suffer from some level of smell dysfunction relative to the control group? I know the control group had 70% correct. Some level of dysfunction means that they're going to be on the left side. So again, let's suppose for our individual, they had 19 out of 40 correct. Again, if they have smell dysfunction, then they're going to be on the lower end of this reference distribution. So this example, or this research question, is going to be one-tailed left. So values as extreme or more extreme than the observed outcome here would be 19, 18, 17, 16, all the way down to 0. Okay? We're going to want to select left tail when we're using our simulation app. So let's go back over to the simulation app. The labels are going to stay the same, but my P, the value that I put in the P box here, is going to be 70%. The number of trials is going to stay 40. Let's get a bunch of outcomes. I'm again going to use 19 here, but I'm selecting left tail now because I want to know if they are worse in their ability to smell against the control group. So I'm selecting left there. Again, take a screenshot of this and dump that into your notes. Make sure and click Upload Image so that it gets saved into the database. Once you have that information, you should be able to answer question number 4 here. Give the p-value, go ahead and make a decision about the test, and then write a conclusion. Make sure and include the 3 parts to the conclusion. So, question number 5. Which research question do you feel is more meaningful? Question number 1 or number 2? If we go back and look at those 2 questions, personally, I think question number 2 is more meaningful. Okay, if we're interested in whether or not they have Parkinson's disease, okay, I would doubt very much that a person that has Parkinson's disease would lose all ability to smell. Maybe in the worst case, but more likely not complete ability to, will not lose their entire ability to smell. For a Parkinson's patient, it's probably going to be more reasonable to compare them against a control group and see whether or not they underperform compared to that control group. So personally, I think research question number 2 would be more meaningful than number 1. Question number 6 just asks you about the following statement. Patient A likely does not have Parkinson's disease because they have the ability to smell, as shown by research question number 1. So suppose somebody makes that statement. I just want you to reflect on whether or not you agree with that statement. Suppose the p-value for research question number 2 was 0.37. Does this change the prognosis of the individual in terms of Parkinson's disease? And the answer to that would be yes. If they're in the bottom 37%, then I guess I didn't obtain the reference distribution. But the reference distribution is going to be obtained under a situation of being like their control group. So being in the bottom 37% is not an outlier at all. And we would say that they would be similar to the control group in that situation. So likely do not have Parkinson's disease if they're not an outlier. If they're an outlier on the left-hand side, then they lose their ability to smell, which is a known condition of Parkinson's disease. So we would expect people with Parkinson's disease to be outliers against the control group. Here's another article that talks about the malingering. And the malingering, again, is the faking about their ability. So if they have built this test, they want to make sure to guard against that situation. They don't want people to abuse their test. So they've made a statement that a score of less than 5 would be considered probable malingering. So less than 5 means you would have 4 or less correct. So I want you to, once again, use the reference distribution app and obtain the probability or the chance of seeing 4 or less correct. So use 4 here in the p-value box and specify left tail because I want to know less than 4. Now that probability, I think that the answer that I got was about 1 or 2%. So it was quite low. So if somebody scores less than 5, then they are probably lying about their ability to smell. So I'll let you answer questions 8 and 9 using the probability value that you get using your reference distribution. Okay, that does it then for Module 2, Part 3, the smell test for Parkinson's disease. Thank you.